Ever wondered why quantum computers are so much faster than the phone in your pocket? It all comes down to how they store information. Think of a classical bit like a light switch. It's either on at 0 or off at 1. Boring, right? But a quantum qubit? That's where it gets wild. In quantum computing, we visualize a qubit using the Bloch sphere. Imagine a literal globe. The North Pole is your 0, and the South Pole is your 1. But here's the kicker. Unlike a classical bit, a qubit can exist anywhere on the surface of that sphere at the same time. This isn't just a 3D map, it's a geometric representation of superposition. When a qubit is on the equator, it's not a 0 or a 1. It's a mathematical maybe of both. So, how do we navigate this quantum globe? We use two specific angles, theta and phi. Theta controls your latitude. If you move from the North Pole toward the equator, you're changing the probability of what the qubit will be when you finally measure it. But there's a secret ingredient, phi. This is the phase, or the longitude. If you spin the qubit around the center, you aren't changing the 50-50 odds of it being a 0 or 1, but you are changing its quantum state. Think of it like a coin spinning on a table. While it's spinning, it's in a state of heads and tails. The speed and direction of that spin, that's the phase. This is what allows quantum waves to interfere with each other, canceling out wrong answers and highlighting the right ones. The coolest part, programming a quantum computer is basically just performing a dance on this sphere. We use quantum gates to move our state around. An X-gate is like a 180-degree flip. It takes you from the North Pole straight to the South. That's your quantum not gate. But the Hadamard gate is the real MVP. It takes you from a static 0 at the pole and kicks you down to the equator into a perfect superposition. Suddenly, your qubit is live and ready for complex math. The Bloch sphere is our GPS for the quantum world. The only catch, it only works for one qubit at a time. Once qubits get entangled, meaning they're linked together, the math becomes too big for a single sphere to hold. Quantum computing is complex, but if you can visualize the sphere, you've already mastered the hardest part.